My name's Graydon Blair, and I'm from Utah Biodiesel Supply. And today we're going to talk about some real simple tests that you can do as a home brewer to check the quality of the fuel. First test we're going to be doing is a water test. And we're going to talk about oil titration test to figure out free fatty acid levels. We're going to do a conversion test, a simple test to see what the conversion level of the biodiesel is. We're going to do a methanol test. While it's not part of the ASTM standard, it's important that you start with pure methanol. We'll talk a little bit about that. And then we're going to do a soap test. I'm going to kind of fly through them, but I've got a handout for, let's see, I'm just going to reach these around and let you pass them around the room. I'll start up here. Everything I'm talking about today is in these flyers. Also, all of the information is on my website as well. We also have tutorial videos. But I wanted everyone to see some hands-on stuff with biodiesel. The very first test we're going to talk about is a water test. Why is water important to get out of oil? Anyone? Because it makes a lot of problems. Loads of problems. You get soap, it screws up the methanol, it screws up the titration, screws up your conversion. So if I can stress anything today, and over the next few days as you sit in some presentations about quality, one of the biggest things you're going to hear is you got to get the water out. Because water is not your friend when you make biodiesel. I got to just move this a little bit over here. So there's numerous ways to get water out. One of the ways I like is through something called a deluxe Sandy Brae water test kit. This is it. We're going to actually do a test. All this does is it uses calcium hydride, and in the presence of water, calcium hydride generates hydrogen gas. There's a gauge on top. It measures what the pressure is, and then that pressure you compare to a scale, and then you're able to see what water content in oils or biodiesel is, clear down to 50 parts per million. So it's very accurate. So let's talk a little bit about why it's used. You'll use it to check water in oil and also in biodiesel. You can also do numerous other tests. There's something called a Carl Fisher test if you've got a really high-tech lab. If you've got a really low-tech lab, you get a hot pan out. Be careful doing this. Heat the pan up warm, like you're going to fry an egg, and you dump about this much and no more of oil in there. You don't want to start a fire. But if you see bubbles, it's a really good indicator that you've got water. But if you want to know exactly how much water, use one of these. Oil titration kit is to measure the free fatty acid level in oil. This isn't Biodiesel 101, so we're not going to go into the chemistry of why that's important, but the real quick answer is the higher the FFA level, the less biodiesel you get and the more soap you get. Conversion test kit is a kit that allows you to test, hey, did I take oil and did I make biodiesel? And how well did I make biodiesel? It's a very simple test that was it was invented by someone over in Sweden somewhere. It wasn't invented, he just discovered it. He discovered that by using 3 milliliters of biodiesel in 27 milliliters of methanol is very, very accurate to running what's called a gas chromatograph test. If you own a biodiesel commercial plant, you'll have a gas chromatograph, you'll make biodiesel when you go and test it. Well, the standard for biodiesel is set at a certain number, and someone did a lot of research with this test and found that if you pass this simple test, you've got a high likelihood of passing the ASTM test. So we're going to do that test today as well. We're also going to do testing for soap in biodiesel. Soap is, again, if you've got water in biodiesel or your FFA content is high, you're going to generate some soap. The higher your FFA level is, the more soap you generate. You'll usually always generate a little bit of soap. Soap's not good, the engines don't like it, it plugs filters, and so we need to get it out. So we'll talk a little bit about that. For those of you that plan on recovering your methanol or reusing the methanol that you make biodiesel with, it's important that you test the methanol to make sure that it's pure. And we're going to test it today and show you that as well. So these are the kits. We'll get right into the presentation here. Everything I'm doing, like I said today, is on that sheet. I have the instructions for doing it, But let's test for water. So again, all you do is you take this vessel open. I have a sample of what I think is dry oil. We haven't measured it, but we assume it's dry. You're dealing with some chemicals. Again, you're dealing with calcium hydride. Calcium hydride is one of the most regulated chemicals we've found for shipping things. We ship things all over the world, and calcium hydride in this kit is very, very expensive. They don't like to put it on boats, they don't like to put it on airplanes, and if you do want it, it's real expensive. Within the United States, this kit runs about $209. It comes with enough reagent to do 50 tests, and it comes with the syringes, instructions. If you look on here, we're going to take 30 milliliters of our biodiesel sample, or oil sample, whatever you're testing. Put it in this vessel. This is just a syringe they ship with it. There's nothing really simple or really special about it. By the way, everything we're showing here today is for sale. We've brought it. We don't want to take it back home. So if you're interested in buying it, holler at us at lunch, and we're more than happy to take it so we don't have to haul it back. Okay, they have something called a reagent bead. It's basically dried paint thinner. There's nothing special about it. It's just there to dilute your sample that you're testing. So it wants 10 milliliters of this. Trick when you're using syringes is if you get a bubble on top, it's easier to tell how much you've got in your syringe. Okay. As I'm putting this in here, I'm being really careful not to spill any of it into the cup where I'm going to put the reagent. So I don't want it reacting yet. Cut it open. There's 350 milligrams, if anyone's interested, of this stuff that he's using. This is made by a company called Brae Laboratories in Delaware. The test was invented for Mobil 1 to detect moisture in hydraulic fluid. I saw it at a commercial biodiesel facility in New Mexico once. Fell in love with it, used it, and they work extremely well. Okay, so I have everything in this vessel. It's sealed, and to get it to work, all I do is I shake it like this a little bit. I'm going to shake it for about 30 seconds. If you look on here, it says that. And then, I don't know if you can see this, but this gauge is actually starting to move. And so there is some water in here that's reacting with this vessel. So we'll let it sit here. If your oil is really wet, that gauge will just floor all the way to the right. You release it with a pressure relief valve and you move up to another scale. Use a little bit less sample, a little bit more of your diluent. This is coming right up to about 3, almost to 4. We'll let it sit there for a little bit. So that's how you do this scale. We're going to let that sit for 5 minutes. I'm going to move on to this while this is registering. Okay. Questions about this before I move on to the next test? Yes?
Is that reagent, is it corrosive, caustic?
Caustic, I don't know that it's corrosive, it just makes hydrogen gas.
I feel like you get it on your skin, it's not.
It's probably not a good idea to get it on your skin.
You would react with the moisture.
That's what I'm wondering, yeah.
It is highly explosive. So
Causes eye and skin burns, so yeah, don't get it on your skin. Flammable solid, flammable hydrogen gas generated upon water and water vapor contact for industrial use only. So yeah.
What's the lifespan of the chemicals that are unused?
If they're kept in a clean, dry place, basically indefinitely. The only problem is if the glue on this comes loose and it absorbs moisture, then it's toast. The reagent itself, as long as it stays clean and dry, again, indefinitely. It's basically paint thinner and paint thinner, unless it absorbs moisture. One day I asked him how he dried this, because let's say you run out of this and you really don't want to pay the money to get it shipped to you because it's expensive, and I understand. Go into the store, buy some paint thinner, take some of your reagent BA packets, get a metal container, kind of like a kerosene can, or a camping gas. I don't know. Wood gas. Tiny little can. He opens this a couple packets, he dumps it in, he seals it, lets it sit there for a little bit. It turns all the water to hydrogen, opens it, lets that out, seals it back up. You've now got dried reagent. That's exactly how he dries his reagent. So.
How do you get more packets?
The packets are available through our website as well. I tell everyone if you're going to be doing more than 50 tests per month, you want to buy additional, because every time you ship a box, it's $40 to ship a box. It's the hazmat fee. Yep.
What's the ASTM allowance? How many parts per million?
Parts per million? In oil, there isn't one. That's a good point. Let's talk about that. So my limits for water, I don't know if I've got, oh I do, yeah. For water and oil, you basically want to keep it below about 2,500. If you're doing acid esterification, take it really down, get it down to 1,000 parts per million if you can do it. The real answer is as low as you can do it economically. But you want to get it as low as you can. My upper echelon, I don't like to get it any higher than 3,000 parts per million. If it's above that, I'm going to be drying it. There's numerous ways to do that. You can chat with us after about that. Biodiesel itself, the ASTM standard, says that you can have up to 500 parts per million water in your fuel. Now that's free water. There's a whole discussion about free and bound water that if you want to have with a couple of gentlemen sitting here that are pros. But basically in biodiesel itself, no more than 500 ppm is what the standard says. Also, I've got the ASTM equivalent for each one of these tests. I also have it on this document, so you can take a look at that. Okay, so we are registering for 4.7. For this test, I'm going to multiply that gauge reading by 0.01 or 100 to get my parts per million. So 4.7 times 100 is 470 parts per million. So that is really dry oil. And that's kind of what we thought it was. We thought it was really dry. So.
And that's my oil. I dried that in my BioPro, which is basically, it just circulates it through the air with the window. I mean, it turns it. It just rolls it over. The lid was off it, so it's open, and I did that about 12 hours. I do that with all my oil. So that was some fish fry oil from last Easter. So it probably had fair water content because, you know, they were frying frozen fish and French fries in it. So there was probably fair water content. I did not test it before I started drying.
So we were curious to see what it was. This is really wet oil. We don't have time to run it, but if I put that in there, the gauge would just go wham, because it's got so much water content. But again, so the limit, I like to keep it under 3,000 parts per million on my oil. I like to get under 500 parts per million on ASTM for biodiesel. So technically, this oil is dry enough for the ASTM standard if it were biodiesel. Okay, that's the water test kit. There's some things that you can get rid of water with. Later on, tomorrow, Norm's going to be talking about it. You can use molecular sieves to remove water from oil and biodiesel and methanol and different things. So hit him up tomorrow for that. Let's move into our next test. Do we have any other questions on the water test? Yes?
I'm sorry, I wasn't late. This test is to approximate the ASTM one that use the centrifuge, correct?
Yes. Yeah. So in the ASTM standard, let's talk a little bit about it. So what do? They throw it in this little device called a centrifuge, and they spin the living snot out of it, and they pull it out, and they measure what the content, the water content and sediment as well, but mainly they're using this test for water, and it's D6751.
Yeah, and this is only for free emulsified water, and ASTM doesn't seem to care about dissolved water.
Right. Exactly. Exactly. So I'm going to pass this gauge around. Don't open it yet. When it gets back up here, we'll empty it and...
Don't press the button.
Yeah, don't press the button either, unless you want stuff in your face.
Be nice now.
Okay, the next test. Oil titration test. This test, the ASTM equivalent to this test is D664, or the acid number. When biodiesel is made, we're using oil. It's got a free fatty acid in it. We have to neutralize that fatty acid before we can start making biodiesel. And again, I won't go into the chemistry today of it. If you don't, you're going to run out of. If you don't feed it enough catalyst, you're going to run out of catalyst, and you're not going to get good biodiesel, which is why we're going to do this test here. But the titration test, we use it for testing oil to identify how much catalyst we will use. I want to stress today's test is a homebrew version of the test. It's not a commercial version of the test. There are commercial equivalents to this test published by the American Oil Chemists Society. If you'd like to see what those are, contact me afterwards and I can send you some information about it. But this test for those of us making small batches is good enough, and it gets us there. And the nice thing about making biodiesel is adding a little bit more catalyst is just going to push it more to completion. And so we use this test to do that. A couple things to talk about when we do this test. We're going to be using isopropyl alcohol. We're going to use some phenolphthalein. We're going to use some potassium hydroxide that's been dissolved in water as our titration solution. When you titrate, you're doing nothing more than looking at a batch. You walk up to some oil and you say, I want to figure out how much of what percentage of this oil has free fatty acids in it. I have a really stupid, simple analogy. Oil molecules look like a 3. They've got a glycerin backbone. They've got 3 fatty acid chains that hang off of them. As they get old, these fatty acids pull off. I like to think of it like they rust at the edge here, and now they're floating in the oil, or they're called free fatty acids. We need to find out how many of them there are. A lot of people get really concerned about when you do titration. Oh, is it right? Did I measure the right number? All you're doing is you're walking up to a barrel and you're looking in it and you're using a test to measure how many of the fingers have fallen off and are in the oil and what percentage those are, because that's going to tell you how much catalyst you're going to use. Okay, so we're going to actually titrate 2 things of oil. We're going to titrate this dry oil, and if we have time, we'll titrate some palm oil. This is actually palm oil for those that have never seen it. It's orange in color. It's fairly thick. I don't know what the temperature in this room is, but it's pretty warm here. I'm sweating, and this is still somewhat of a jelly. So palm oils, don't get it on your skin because it stains like no tomorrow. Hey Norm, do you want to start pulling this kit down?
No. Oh, wrong answer.
He's going to come up, keep me going here. To titrate, I have taken 1 gram of potassium hydroxide and I've dissolved it in some distilled water. Where's our titration? There it is. Right here. 1 gram to 1 liter of water. And I'm going to use some isopropyl alcohol. The color, you can ask him about why it's pink later, but he's put a couple drops of phenolphthalein in there, and it lets us know that what the color is.
Yeah, because on your workbench, you're going to have isopropanol, you're going to have methanol, you're going to have distilled water, you're going to have that solution. They're all white, they're all clear. When I make up the solution, I put a couple drops of phenolphthalein in it. Gives it a nice lavender color. You can reach for it, you know it. Because you're going to be, if you're titrating much oil, you're going to be using it a lot. And that way, you can grab it. It's easy to identify.
One thing that's important to realize is this stuff goes bad. It starts carbonating with the air the moment you put it together. So if your titration solution is bad, or if it's been more than 90 days, you need to be making new titration solution. It's cheap enough to make. You get some distilled water, you get catalyst, you put it together, and you've got new stuff. had a lot of people that call in and say, oh, my stuff's not working real well. So when was the last time you remade your titration solution? Last year. Let's do that as your starting point. So if things look weird, that's a really good place to start. To titrate, I'm going to cheat and use a really cool device called a magnetic stir. This is a portable stir that I like. I'm going to put 10 milliliters of isopropyl alcohol in here. I'm going to put 1 milliliter of the oil in here. If I was scientific, I'd have a scale out and I'd be measuring the oil. But again, this is a small scale homebrew style, so this will work for us, what we need. The magnetic stir is just a tiny little bar. Goes in here. But darn, it's cool and it does a good job. Okay, this is spinning for those that can't see it. Okay, isopropyl.
And it will spin for about 3 days on one AA battery, so you do want to shut it off if you happen to not think about it and leave it on. Why, it doesn't cost much to regenerate it. I don't want how much stuff goes back in here.
Just like that, and then things go right there. And then when the kit comes back up, we'll throw it in.
Yeah,
Okay. Safety discussion's a little nice, we didn't quite have it, but wear gloves as you're doing these tests. If you have goggles, it's a good idea. For titration, I don't think you've really got to have goggles, but I've got to say that, so wear goggles if you have them. Basically, I could drink the titration solution and it's less toxic than soap. I don't recommend that you do it, but the toxicity of it is very, very low. So, those out there that are concerned about it. Okay, I had a 5 milliliter syringe. There it is. Again, I'm putting a bubble on top of this just to make it easy for me to see where I'm at. I'm curious what this titrate's at too. So I now have my oil and my titration solution, or my alcohol going. Then what I'm going to do is with another syringe, it's important that you use clean syringes, otherwise things get nasty. Or you actually will get contaminated oil. So I've sucked up 10 milliliters of titration solution. That's what I'll be using. Before I do that, I need an indicator. This indicator is phenolphthalein. It indicates change in pH from one end to the other as I climb up the scale, and it changes at about 8 to 8.5. There's a couple other pH indicators out there. If you've seen some of our videos, you can use turmeric from the grocery store. It actually works. It makes a really cool blood red when you use it. You can use phenolphthalein, which is what I like to use, or you can use phenol red. If you're being pure about what the chemists and such use, phenolphthalein is the one to use. So we're going to put a little bit of phenolphthalein in here. Doesn't matter how much you put in. Just need to put in enough to make it go. I'm going to put about 3 drops in. It didn't change color. Okay, let's see if I can hold this up and you guys can see it while I'm doing it. What I'm looking for is a color change. Almost immediately. Wow, that is good oil. I almost say that's it. Let's make it go. You want color change, and you want it color change and held for about 20 seconds. This is, to me, this is almost color change, so. Did we put our oil in there? Yeah, I did. Wow, that is good.
Did you put your oil in there?
Yeah, because I got the oil syringe laying
You got
there.
the syringe, empty, you have it in there.
Yeah, this used all of 1/4 of a milliliter. How many of you have made biodiesel homebrew before? How good is that oil? It's really good oil for homebrew. Most of the time we're dealing with oil that's, I don't know, 5 or 6, crappy. But that oil turned really good. I want to.
So the secret to that oil is, for those of you who are Catholic, you got it made. You got the fish fry at Easter. That's, I live in the city of 275,000. There's 4 fish fries in town. I get the oil for 3 of them. So that oil hasn't been used 2 hours. Hour and a half, maybe 3 at most. And
So
that's good oil.
Let's talk about what that number means. So it took 0.25 milliliters of titration solution to turn this pink. It's kind of going back normal. Let's get it a little bit more red.
Yeah, if you get a couple minutes, those carbon
Yeah.
dioxide's gonna make it go back.
You see how purple that is? Okay, let's talk about what the math means then. So it took 0.25 milliliters of this solution to turn that, the color. In other words, I walked up to that barrel, I looked in, and there were very, very few fingers. What does that translate to in a free fatty acid? On this sheet, I've got, bump that up. There's a conversion factor that someone that was much smarter than I figured out one day, that based on what your titration comes up at, 0.25, you can times that by a calculation right there. It's 5 divided by 1.8. So I got 0.25 divided by 1.8. This oil is roughly 0.14% FFA. It's really, really, really good oil. Let's suggest that this oil took 5 milliliters, because that's normally what people see. So if I had 5 milliliters that it took, again, this is a KOH-based solution, and I've divided that by 1.8, that's 2.8 free fatty acid content. So there's, of that oil, 2.8% of it has a bunch of fingers in it. So I'm going to have to neutralize 2.8% of that oil. With our oil, we're going to have to neutralize 0.13, very, very little. So it's not going to take a lot. To figure out how much catalyst you're going to use, I've got the catalyst calculation here. Basically, when we make biodiesel, if I had brand new oil that titrated at absolutely 0 and I was using KOH on a small scale, for every liter of oil that I wanted to make fuel out of, I would use 7 grams of potassium hydroxide. There's some math behind why we use those numbers in homebrew. In commercial applications, they actually use a little bit less because their equipment's a little bit more efficient than ours. But on a small scale, that's usually what we start with. So if I was using 100% pure potassium hydroxide, for every liter of oil, I'd add 7 grams. If my potassium hydroxide was absolutely pure, which it's not. So I actually have to calculate a purity calculation on that. So what you do is you take the purity, which is about 90%, and you take the 7 and divide it by 0.90. That gives us a new base of about 7.8. Okay? So for every liter of oil that I'm using potassium hydroxide, that's about 90% pure, I'm going to use 7.8 liters, or grams per liter of oil. Let's talk about that for our oil. We had 7.8, we call that a base. So if I had 7.8, I'm going to add my titration of 0.25. I get 8.05. So for every liter of oil, I'm going to add roughly 8 grams. If I want, I can round up to 9. And I should get well-reactive fuel if it's dry, which is why we talked about the water test. So, questions about titration? I know I'm kind of moving fast, but time's creeping fast. Okay, cool. Or if you want to chase behind me on this one, I'll go on to this next one. The next test is, in my mind, one of the most important tests you can do when you make biodiesel on a small scale. And that's to figure out if I have oil and I made biodiesel, how well reacted did I make the oil? Did I make biodiesel? And that test is called a biodiesel conversion test. some wise man, like I said earlier, figured out that if I take 3 milliliters of methanol, or I'm sorry, biodiesel, add 27 milliliters of methanol to it, shake it, let it sit for a minute. If it fully dissolves that biodiesel at about 68 to 72 degrees Fahrenheit, there's a really high likelihood that I'm going to pass the ASTM standard for biodiesel conversion, which is the total glycerin test. It's ASTM D6584. I actually was part of the group that did a lot of this research. And the guy took oils of all sorts of different titrations. He made all sorts of different tests. And he had a gas chromatograph to play with. And what they found is that if your methanol is between 68 to 72 degrees Fahrenheit, and so is your biodiesel, and you use this test and you pass, hey, you've made really well converted biodiesel. Does it pass all the other ASTM tests? Because there's about 16 tests in that. No, but at least we got biodiesel. So let's do that test. Okay, that's this one, right? Is that unreacted fuel or reacted but
Unwashed, that's just freshly reacted.
this is freshly reacted, unwashed fuel.
Still even got the glycerin on the bottom.
See that? There's our glycerin level. This fuel was made in a BioPro, which is an automated biodiesel processor on a small scale. They're fun to make fuel in. It doesn't make fuel any better than anything else, but what it does do is it gives you your time back if you're a small time producer. And on a small scale, if you ask me to make biodiesel any other way, I'll die before I'll let my BioPro go. I like it that much.
Is that why that oil titrated so low?
No, it titrated low because it was used low.
Yeah.
They didn't use it a lot.
Even after you react, it doesn't change.
The titration of the biodiesel after you've reacted it should have a titration of like 0, because you hopefully have reacted all those free fatty acids into biodiesel.
Because that's the oil you put in the titration test.
This was right there.
Oh, you put it in that one?
Yeah, this is different oil here. This is biodiesel.
Yeah, that's biodiesel.
I've got a quick question.
That is this after we do our thing with it, chemically.
Is that soy-based
Yeah.
oil?
Yeah, yes.
After you put that catalyst inside of it, right? So to test for the fatty acid.
Pardon?
After you put the catalyst in to test for the fatty acid, right?
That's what the yep.
Catalyst does. You react with it and attach to it, right?
Mm-hmm.
Okay, what do you do? Then you have to filter it out after, right?
The biodiesel?
No, yeah, but how do you get rid of it? When you're going to react with it and just dissolve in the oil?
No, you dissolve the catalyst in methanol,
Right.
and then the methanol goes into the biodiesel, and what happens is the biodiesel creates, it's a chemical conversion, and you literally, put that in the light, you literally get glycerin that settles out, so the catalyst has reacted with the free fatty acids to make soap, and a lot of that soap ends up down here, but it also reacts with the methanol to make biodiesel, or this top layer.
The top layer is what you want. The bottom is what you use.
Yeah, that's what you discard. Yep, and then you have to cleanse that. So, okay, so I've got 27 milliliters of that in there. I'm gonna cheat and suck out of my methanol. And I've got 3 milliliters of, you know what, I did that completely backwards.
Oh, I wasn't even paying attention.
You want 27 milliliters of methanol, 3 milliliters of biodiesel. I don't want to contaminate that, so
more.
cup or tissue cup. That's what happens when you have a bright light in your eyes. Proof that even the guys that are supposed to know what they're doing sometimes don't know what they're doing.
He's speaking for himself.
Okay, 27 milliliters of methanol. 3 milliliters of reacted biodiesel. Okay, this, I don't know if you can see it, but it kind of went cloudy and then now it's starting to go almost crystal clear. Well, it's still cloudy, but it's going clear, and it's going clear fairly quickly. We'll let this sit for about 5 minutes and we're measuring it. Like a cooking show, any good cooking show host already has one pre-done. I'm going to pass this around, and if you look in the corner of it, it looks like this little droplet sitting here. Okay? That tells me, based on this test, that I didn't get good biodiesel, or I didn't fully react all the oil all the way, and I have a high likelihood that I'm going to flunk the ASTM standard for total glycerin. In other words, the most important thing when we're making biodiesel is to take oil and make biodiesel. I didn't do it all the way. So, and in this case, I've got over a 1/4 inch of fallout in this corner. And this test that was done, let it sit on the corner, it's not quite so much. So I'm going to pass these around, pass one this way and pass one this way. Where's the water test kit? Where did it end up? Okay, can you bring that up to me? No, both of these kind of failed.
So what that means is that you didn't put enough catalyst inside.
Or there was water, or the oil was bad, or I didn't give it catalyst, or there's numerous reasons why you will fail this test.
So you don't want the whole process over again.
You reprocess this fuel. You'll add more catalyst and whack it again. Yep.
You don't want to see any residue.
I want none. I don't want any fallout in this at all. And this is starting to show us that I don't think I'm going to get any. There might be a little bit on the bottom there.
It might be a little warm in here. You might be getting little falls too.
Yeah.
I did not get any fallout when I did the 3.7.
Basically, you want no fallout. You want this to be crystal clear. Cloudiness I really don't care about. I just want the fallout in the corner down here there to be nothing. Yes, Dan?
Might want to say why you want.
Sure, that's an excellent point. We have some great experts in the room. One of them is a diesel mechanic that works on diesel engines that people feed biodiesel all day long to up in Seattle. This is Dan Freeman. I've got a shout out to him. And if you want to learn about, or you want stuff about diesel engines, he's great over here. Dan, what happens when we feed unreacted biodiesel to diesel engines?
You plug filters, and plug filters cause very expensive damage, like to injection pumps and injectors and everything that you can imagine.
What else does it do? John Banker.
That about sums it up.
And it really makes the engine makers mad. That's why I have such warranty problems with biodiesel today, because people are using poor fuel. I have 73 Ford Power Stroke. I had over 200,000 miles on V100. I really never had a head off it. So, I can definitely tell you what.
Also remember that the federal government for manufacturers mandates that certain parts have a certain lifetime. And this is one of the real issues that the auto manufacturers have with the use of any new fuel in their vehicles. They need to test it out and make sure that the governmental mandates can still be met with their vehicle operating that kind of fuel. And so these problems don't necessarily show immediately. You probably use that fuel for some period of time, and then a year down the line you've got some major problems. It's not the case that you put that stuff in necessarily. There are times that can happen. You put that stuff in, you run it, and so much you run it great for a while, and then suddenly you have all these problems that start happening.
It's not good. You want to pass. Now, will diesel engines burn unreacted fuel? Yeah. I mean, there's guys running vegetable oil in diesel engines all day long, and it works. But eventually, if you're running particularly unreacted biodiesel, you're going to run into potential problems. Will Bob's tractor that's 50 years old run it? Yeah. Would I put something like this in a Ford 6-liter? No, not anywhere near it. Would I put it in a Duramax? I might. Let me give you my rule of thumb I use on this test. So pass is what you really want, and I kind of have some rules of thumb. No fallout, biodiesel is likely to hit ASTM standards. If you're 0 to 1/8 of an inch of fallout in the bottom of that vial as you hold it at a 45-degree angle, Usually you can burn that in a diesel truck and it's not going to bother it. It's just not going to bother it. And that's usually okay for most diesel engines. If it's an 1/8 to 1/4 of an inch and you're holding that vial as it's going around, it's probably okay for indirect injected engines because their tolerances are wider and it's a little bit easier. If it's over 1/4 of an inch, one of these is over 1/4 of an inch, flat out fail. I won't let it anywhere near my diesel engines, period. Because it's just not reacted well enough and I know it's going to cause a problem. It might not cause a problem with this batch, but down the road I'm going to get in trouble with it. So that's kind of my rule of thumb I follow with this test. Okay, we're going to talk a little bit about methanol testing.
Quick question.
You bet.
I heard that the 327 test picks up only the triglycerides and not the monos and dyes. Is that true?
It picks up the triglycerides and diglycerides. It's not real good at the monos.
Okay.
For the monos, there's a test out there called the flip test. That's pretty good. I don't demo that test here, but you can read up about it. However, I will say, if you pass this test and you pass it with a fair amount of really good and you get no fallout, there's still a high likelihood you'll pass the full ASTM for total glycerin. We found, but that's a good point. This test does not show monos real well. Yes?
First off, I was hoping you could restate, what was, you said you were with them when they were developing this test. What were they comparing against, like the standard?
Sure, you bet. So the ASTM standard is D6584. You use a gas chromatograph to do it.
Is it the whole GC derivative?
Gas chromat, yep, and they do the fun things. A guy named Bob Armentrout and another guy up in Washington made lots of batches of biodiesel, unreacted, really well reacted, all sorts of different oils, and they made them and they tested them. And they would test them as a 327, and then they would test it on the gas chromatograph, and they would compare the results.
Okay. And then using 27.3 conversion, what's the newest model of vehicle you'd be comfortable putting that biodiesel into?
That's a loaded question.
I just want to know what
Is it your vehicle or mine?
Yeah. Let me give you a real quick answer because I don't have a whole lot of time left. I would not put biodiesel that passed this test in anything 2007 and newer. And that's because of a different issue that maybe someone will get into. If you grab me at lunch, I'll tell you about. And that's because there's a diesel particulate filter on it. Now that's burning B100, 100% biodiesel. There's issues with it. But anything previous to 2007, I'd run it. If I pass this test, I'd put it in anything. I have to caveat that. I won't put it in a 6-liter diesel Ford. I just won't do it because the 6 liter is a bad engine to start with, in my opinion. That is my opinion. There's a mechanic over here. You can ask his opinion of it. I just won't do it because I've had too many people have too many problems when they put biodiesel in 6 liters.
I'll bug you at lunch.
Yeah, and the mechanic over here will have a better answer for you. He's had success with 6 liters. I just won't go near it.
I'll give you one quick note that the 327 sample that Graydon sent over there sent down, that is the same fuel as the one that passed, only about 20 minutes into the base process, I just dipped a pitcher out of the top of the processor and poured that off. So that is that fuel about 20 minutes in. It takes about an hour normally. If your water is low, your temperature is right and everything else, it takes an hour to process. So that is just during the process. That's the only difference, it was just short.
9:15 or 9?
9:15.
Okay, so I've got a little bit more and then I'll try and go quick. I'm going to kind of go a little bit faster just because we don't have a whole lot of time. If you're making biodiesel and you have a methanol recovery system to recover your methanol, you're going to want to test that methanol. Remember I said at the beginning that if water is anywhere in the process, it's going to gum it up. Well, one of the places that water can go is in the methanol when you recover it. And so this test isn't particularly an ASTM test. Notice there's nothing below it. But when you're making biodiesel, you should start with pure methanol, as pure as you can get it. If you buy it from a store or a petroleum provider, it's going to be about 98 to 99% pure. I've tested various samples and that's where it sits. If you use recovered methanol with water in it, you're going to generate a little bit of soap, your reactions might not go so well. So it's a good idea to test that methanol. To do that, it's a very simple test. You get a hydrometer, you take the temperature of the methanol, you put this in, you compare where the hydrometer says what its reading is against a reading in a chart, and then you compare it and you're able to see what the purity is. Because we're short on time, I'm not going to go through this, but if you want, you can come up and see this. This hydrometer is sitting right about 90, 85, 86, 87, 870. If you want to figure what it is.
What's the temperature?
Temperature is 87 degrees Fahrenheit. Basically, you take those two numbers, what the specific gravity is, what its temperature is, you compare it to a chart of what pure methanol should be at that temperature. So do some math, and you'll be able to figure out what your what the purity of your methanol is. Again, it's all on this paper that I've given you, so I'm not going to kind of get into it. But I want to get into soap testing because soap is really important.
What did you say the reading was, Barry?
Reading is 8.5. 860. It's right between 860 and 870. 10, 9, 8, 7. Yeah, 865. Okay. Okay. This next test is really important to be done. I would qualify this test as the second most important test you can do, and that is soap testing. The ASTM standard doesn't really have a soap specification in it, but it does have a specification for sodium and potassium, calcium, and magnesium. Some smart chemist somewhere figured out that if you know what you started with, catalyst-wise, sodium or potassium, and you measured the soap content, there's some math that you can do backwards to get to what your sodium and potassium levels will be. And so we're going to show you that test, and that'll kind of conclude so that the next person can get ready and go. But I noted that it's important that it's actually not in the ASTM, but this is a roundabout way of figuring out what if you're near that spec. Okay? To do this test, you're going to be using a lot of isopropyl alcohol. You're going to be using some bromophenol blue. You're going to be using some hydrochloric acid in a very dilute version. This is 0.01 normal. I could drink it. It probably won't hurt me. It's not a good idea. Again, I don't recommend it, but it's not terribly. It's so dilute I can send it in the U.S. mail, and the U.S. mail is really a stickler for what they'll let us send. Bromophenol blue is a pH indicator, much like phenolphthalein, only it's going to indicate on the other end. So let's get started and play with some fuel. Okay, this is reacted fuel. This fuel is reacted fuel that has not been washed. We'll also have a lot of soap depending on what it titrated at. This is fuel. This is beautiful fuel that someone made and used a dry wash system with. And tomorrow, if you want to learn about dry wash, ALX Enterprises is here and they're going to do a good one. This was actually dry washed inappropriately. And it has fairly high soap content. If we get time, we'll do that. This is the product that it was dry washed through, but I bring it to talk about the fact that dry wash is wonderful and people are all gaga about it. But if you don't do it right, can anyone see the soap in there? No. Doesn't look like it. And if you do one of these tests, it's not that bad, but if you do a real soap test, that's where it comes out. I can't stress enough, if you plan on using dry wash, you need to be soap testing. Because visually, this fuel looks beautiful, but it's loaded with soap. A couple of really quick tests for doing soap. One of them is called the shake 'em up. Yes?
I'm sorry, I just want to include, even if you do a water wash, remember that if you've got well water or something like that, you may actually have a high soap load. So even though you're water washing, the fuel will come up really beautiful, you actually may still have more soap than you actually typically like. So you might even want to do a soap test on your water.
Absolutely. Years ago, when biodiesel on a homebrew scale kind of kicked off, someone came up with the idea that, hey, grab a jug, throw some biodiesel in it, shake it, let it settle for a while, and look at the water on the bottom. We called it our shake 'em up test. These are 2 samples of biodiesel that were made, reacted, glycerin was dropped, and then I just stuck them in this jar and I let them settle out with some water, and I shook it really, really good. This jar is really, really cloudy with the water on the bottom, and this jar is crystal clear. The shake 'em up test, what they claimed is that if it was really, really clear, there's a high likelihood that the soap content is pretty much gone. Over the years, we found that not to really be the case, but I bring this test up because it's a good starting test before you start wasting chemicals to do soap tests. If you don't pass this test, you're gonna flunk that test. Don't do that test until you pass this test. And this test is you just grab a jar, it's called the Biodiesel Soap Test Shake Test. Grab some water, distilled water if you got it, put it in a jar, shake it, let it sit for an hour. If your water looks like this, keep on washing. If it's coming out like this, hey, it's time to grab a sample and let's do some soap testing. Okay? So, let's see what this comes up at. The way you do this test is we add 100 milliliters of isopropyl alcohol. It's plugged in. Yep. In a magnetic stirrer. I can't stress enough to use a magnetic stirrer. I tried using it with my hands, just shaking it, and it just doesn't work. So get a decent magnetic stirrer. This little one will work if I had a small enough beaker, but use a magnetic stirrer with this test. You really can't cheat on this one. We're going to add 100 milliliters of isopropyl alcohol. There's some debate on whether the alcohol needs to be pure or not. You want it as pure as possible, but we have found that 91% actually will do a decent job, because if you're using oils that have, turn that off, a fair amount of fat content in them, there have been some that have said that the water in there will allow the indicator to grab it a little bit easier. But for homebrew, again, it's as close as you can get.
So that's 100% isopropyl alcohol?
This is 99% isopropyl alcohol. Yep. And we carry that if you can't find it. Again, everything I'm doing here is available through us. This test is really important to use very accurate measuring tools. These are called glass pipettes. Many of you have seen them. This one's extremely important that you don't cross-contaminate. And so important so that I've labeled my pipettes at home and I keep them clean all the time. I will never use this pipette with the oil or this one with the HCl or vice versa, so I always know it's always been in only one thing, and then afterwards I always clean it with my isopropyl alcohol. Okay. But to load this I can cheat and use one of these. I'm going to use 12 milliliters of biodiesel. Basically you're after 10 grams. There's also an AOCS equivalent to this test if you're interested, and I can give you that later. But this is kind of the homebrew method that someone came up with. You can do this 2 ways. You can put the biodiesel in it first and then turn it blue with bromophenol blue, or you can put bromophenol blue in the solution and then add the biodiesel. Either way works.
Actually, don't you want to put the bromo in first so you blank it? I do.
Yes,
I
you
wonder
can.
why you don't, but
You can.
because if your isopropyl gets a little older, it's going to be a little more acidic. So of course that's going to.
Mr. One.
This test is very narrowly defined on the parameters, so you want to make sure that you're right on the tipping point.
This is nothing more than a cheap pipette. There's lots of expensive pipetting tools out there, but it's accurate enough it lets us measure. And my goal here is just to turn this blue. There's a chance that it might not. If it doesn't, there's a chance that either your biodiesel is acidic or your isopropyl is acidic. We're using brand new methanol or isopropyl, so it should allow us to go blue. Look at that. See it go blue? I'll hold it up for everyone. I can't see. Getting blue. I like to go pretty blue. Nice and blue. Okay, here's where it gets real important. Was fit in here? This is my HCl. This test, I'm using a very, very, very small pipette because the numbers I'm using are very small when I figure out what my soap content is. I mean, we're dealing in 0.05 of a milliliter for soap content. Okay, so I'm going to suck up about 1 milliliter. We're going to see where this turns. That's not one. Okay, there we go. I'm using a bigger pipette pump with this pump the pipette than I really should. You want to try and start with a a little bit smaller pump. Okay, so I'm sitting right at 0, and then if I get down to here, I go to 1. See what it takes. This possibly should have a lot of soap because I've not washed this fuel. Okay, so there's 1. So I know that it has more than 304 parts per million.
You have 10 more minutes.
Pardon?
You have 10 more minutes.
Okay, thanks. There, it's starting to turn. See it? It just went to green. Let me hold it up. Those that can't see it. Put it in the light here. So I started out deep blue and I'm going green. I'm going to let that stir for a little bit and see what happens. This is where if you're just shaking it with your hand, it's just not very accurate. You want a magnetic stir. There's varying degrees of agreement out there onto what color it should really turn. Just a slight change in color, people will measure it. Some will measure it when it goes yellow. I want to take it to yellow just to show you. So I had 2. There it's going. Look at that yellow. Almost looks just like pure biodiesel. Or Mountain Dew. Okay, so to get it to go to green, it took 2 milliliters. To get it to go to this yellow, it took 2.05. I'm going to ask our chemist here. Would I measure it when I just went to green or yellow?
Usually you should do it all the way.
To yellow? Okay. For those that
There wasn't a
don't...
big difference anyway.
Huh?
There wasn't a big difference anyway.
Right, because I was on off 0.05. Okay. This is the chemist, this is Gary. For those that don't know, most of the chemistry that biodiesel was based on in the US for ASTM and different things, these 2 gentlemen sitting here did. So these are, we have like the God 1 and God 2 of biodiesel sitting in the room. So if I screw up, they'll tell us. Or they'll be nice and not and then come up afterwards. But okay, let's figure the math out. So this was a KOH or NaOH based batch, Norm?
Kaylee.
Okay, so for that one, if it's KOH, we use a figure of 320 multiplier, okay? There's some chemistry behind why we do that. It has to do with moles and different things, but that's the multiplier. R10, which is a media that you're going to hear about, soap tested at 1250. Does it look nice? Looks great, right? So again, I can't stress enough, a visual test is not good enough. You've got to soap test. So, I think I'm done. Is that right?
Yeah, questions.
Questions? Okay. I'll take about 5 minutes of questions, and we need to let the other speakers start. Go ahead.
If you do the shake 'em up test and it's coming out really clear, but it fails the titration test, how do you wash the soap out?
You use the same method that you did to wash it before.
It's just when you see that clear water, there's still soap in it, evidently.
There is. Yeah, so what that means is you need to wash it again.
Yeah.
You need to keep washing it until your soap levels get down to the acceptable levels.
Right, so you might not see the soap falling out then.
You're right. Not in this test. And that's why I say this test is a good gut check to let you know you're in the ballpark to start testing, but it's not an accurate test. Yes?
It doesn't have to be dry to be tested this way, though.
No.
Okay.
The water might get, no, in the test we've done, no. It's probably a good idea. Gary, chemist?
Well, I mean, you should have it dry as possible anyway, so.
So if you pull a sample out before you test it, dry it down? Because this is a test some of these people are doing after they've reacted, but before they've fully washed it. Or they've actually washed it, not dried it.
But are you asking, should you dry it
Well, I don't
you
want-
test, or dry it before
Yeah.
you put it in your truck?
No, do you want to go through the process of drying it and then testing it? And what if it comes out dirty? You have to rewash it and dry it again is the point. Just for the test.
You don't have to dry it before you do the test.
Okay, that's the only question.
I found that it will soap test a little lower if it's dry, but through the Magster, 10 minutes, 5 minutes, spin it, it'll dry. And then you can test. I get 50 points per million less probably.
If it's dry.
Yeah, and when I dry it rather than do it, just dipping it out of the tank.
So it might be a good idea to dry the sample if you've got time, but if you want to see where you are gut check, you can go ahead. Other questions? Someone had one back here? Okay. Yes?
I just have a comment for those of you who are doing some of this testing, especially the 27.3. In our laboratories at the UCSD, we did a lot of comparison testing for 27.3 and CBC, and it can't be emphasized enough how you have to be within the right temperature.
Yes.
Yes.
Cannot be emphasized enough.
Right.
You can get anything to pass if you get it hot enough. Right now, I'm in Sacramento, I'm graduating now. It's like 105 out there. No matter what I do, it'll pass unless they put it on ice. So, as a slight modification to it, if you're in hot weather, take your sample, throw it in the fridge after you throw it together. Bring it out. It'll always leave it in the fridge until it's cloudy. Bring it out. Wait for it to clear in a second. Clears, measure your temperature. If you're with the temperature range, you're good. Or if it has to be hotter than that when it clears, then pretty much fail.
That's so true. If it's too hot, the test can give you a false negative. In other words, it will dissolve more of the biodiesel than it should. If it's too cold, it can give you what's called a false positive, meaning that you'll see biodiesel show up as a fail when in reality it might not have failed. And that has to do with the amount of biodiesel methanol can absorb at different temperatures.
So is it best if you plan to sell this thing to have a control room when you do the test?
Yes, absolutely. Good point. If you plan to sell this, it is imperative that you have a controlled room somewhere away from your thing, preferably, where you can keep all this equipment clean and you can control the temperature, you can control the humidity. Absolutely. Yeah. Now, if you're making it on a small scale and doing it in the shed and it's just your own fuel, can you get away with it? Yeah, a lot of people do. But if you're selling it, I can't stress that enough. Do it right. Don't give us a black eye. Other questions? Okay, I'm going to turn the time over to start cleaning up. We've got our next presentation, but thank you for coming. If you have questions, also I'm going to do one real quick plug for a couple things. there's a video, if you're starting making biodiesel and you want to see these tests and keep it on hand, there's a video that we offer on our website that was put out by a guy that did all these tests. It's called BioLyle's Biodiesel Workshop. It's excellent. It's $39.95. I've got some here if you want it, but it does all this so you can keep it in your house. I've also got all these things on YouTube, a lot of these on my website. If you have problems, I've got my phone number on there. We offer all these. We're happy to sell them to you at lunch.